Hello friends, you are watching channel number collage. The purpose of this channel is to take sincere efforts to make you understand and like mathematics, science and engineering in a simple and easy manner. In the previous video, we have discussed the concept of centroid of composite sections and some problems based on that. In this video, we will discuss more problems on centroid of composite sections. Find the centroid of the section of a concrete dam shown in the figure. This is the section of a concrete dam. This dam section is not symmetrical about horizontal or vertical axis. For finding the position of centroid, we have to find both x bar and y bar. So, we will divide the section into two rectangles and two triangles like this. Two rectangles, these two rectangles, and two triangles, these two triangles. For finding x bar and y bar of this section, we draw x-axis along the bottom edge of the section here and y-axis along the left corner of the section like this. The areas of the subsections A1 equals half multiplied by 1 multiplied by 5, which is 2.5, which is the area of this triangle. A2 equals 1 multiplied by 6, which is 6 meters square, area of this rectangle. A3 equals half multiplied by 2 multiplied by 4, which is 4 meter square, which is the area of this triangle. A4 equals 1 multiplied by 3, which is 3 meters square, which is area of this rectangle. The moment arms of the centroids represented by these areas from the vertical y-axis are x1 equals 2/3 multiplied by 1, which is 0.66 meter. X2 equals 1 plus half multiplied by 1 equals 1.50 meter. X3 equals 1 plus 1 plus 1/3 multiplied by 2 equals 2.66 meter, which is this. X4 equals 1 plus 1 plus half multiplied by 3, which is 3.50 meter. X4 is 3.50 meter. The moment arms of the centroids represented by these areas from horizontal x-axis are y1 equals 1/3 multiplied by 5, 4 plus 1, 5, height of this triangle multiplied by 1/3, which is 1.66 meter. Y1 is 1.66 meters. Y2 equals half multiplied by 6, 1 plus 4, 5 plus 1, 6. Height of the rectangle multiplied by half, which is 3 meter. So y2 equals 3 meter. y3 equals 1 plus 1/3 multiplied by 4. 4 is height of the triangle, which is 2.33 meter. So y3 is 2.33 meter. y4 equals half multiplied by 1. This is 1 and half, which is 0.5 meter. So y4 is 0.5 meter. Values of areas of the 4 subsections and the distances of the respective centroids from the y-axis and from the x-axis have been provided here. These are the 4 subsections. We have x bar equals a1x1 plus a2x2 plus a3x3 plus a4x4 divided by a1 plus a2 plus a3 plus a4. After substituting the values and calculation, we get x bar equals 2.05 meter, which we show like this. We have y bar equals a1y1 plus a2y2 plus a3y3 plus a4y4 divided by a1 plus a2 plus a3 plus a4. After substituting the values and doing calculation, we get y bar equals 2.13 meter, which we show like this. So, the position of the centroid of this diameter section is here represented by G 2.05, 2.13. Find the centroid of the composite section shown in the figure. With respect to the axis as shown. The x-axis is shown like this and y-axis is here. This is not a symmetrical section. We have to find x bar and y bar both. For this, we will divide the section into 3 subsections: a semicircle, this, a rectangle, this, and a triangle, this. Area of semicircle A1 equals half pi r squared, where r is 3. A1 is 14.13 meters squared. Area of rectangle A2 equals 7 multiplied by 6, which is 42 meters squared. Area of triangle A3 equals half base into height, which is 12 meters squared. A1 plus A2 plus A3 equals 68.13 meters squared. Here G1, G2 and G3 are the centroids which represent these areas. Moment arms of the centroids represented by the areas. From y-axis, x1 equals minus 4r divided by 3 pi, which equals minus 4 multiplied by 3 divided by 3 pi. Here r is 3, which is minus 1.27 meter. Here x1 is negative because this distance is on the left side of y-axis. x2 equals half multiplied by 7, which is 3.5 meter, x3 equals 7 plus 1/3 multiplied by 4, which is 8.33 meter. So this is x3. Moment arms of the centroids represented by the areas. From x-axis, y1 equals r, which is 3 meter. y2 equals 6 divided by 2, which is 3 meter. y3 equals 1/3 multiplied by 6, which is 2 meter. Areas of these three subsections A1, A2 and A3 are given here. Distances of the centroids represented by these areas from y-axis and from x-axis have been provided here. We have x bar equals a1x1 plus a2x2 plus a3x3 divided by a1 plus a2 plus a3. Substituting the values and evaluating, we get x bar equals 3.36 meter, which we show like this. Y bar equals a1y1 plus a2y2 plus a3y3 divided by a1 plus a2 plus a3. Substituting the values and evaluating, we get y bar equals 2.82 meter, which we show like this. Now x bar and y bar distances intersect each other at a point G, which is the centroid of this composite section, and G is represented as 3.36, 2.82. So this is about centroids of composite section 2. In the next video, we will discuss more variety of problems on centroid. If you like this video, please do subscribe this channel to get more videos on applied mechanics. Please give your comments and suggestions on our work. Thanks for watching. Keep watching Number Collage.